everyone. Today I'll present to you the various challenges we have at Criteo for managing the server lifecycle. Criteo is an advertisement company. We are present in many of the ad tech segments. I invite you to go to the website to learn more about what Criteo does. My name is Anisse Astier. I've been working at Criteo for a few years now. You can find a link to my personal website. Before that, I was an embedded engineer in the industry for about 14 years. And I'm here today as an SRE in the hardware team, which is responsible for servers. So SRE means Site Reliability Engineer, and reliability is something we deeply care about. Criteo Infrastructure is a group inside Criteo with about 60%, a bit more or less, with 9% that are only responsible for the server scope, only the servers. We have about 40,000 physical servers across multiple data center collocations in the world. On 3 continents, 1 million CPU cores, physical CPU cores, about 700 petabytes of storage, multiple different server vendors, and we also have different types of server in the infrastructure depending on the use case. We call them flavors. For example, for compute, I/O, or storage. Today, we'll have an overview through the server lifecycle. It will be a bit quick. We won't be able to go in depth in every subject. So the first step we have when we want to have a server, before even having it, is the selection process. And that's part of our responsibilities. Selecting a server means many things, looking at what's available on the market. And it means getting a sample at some point to test it. And the traditional approach we have to test servers is a manual one. And it's a very, very long process because we do benchmarks to be able to get the most optimized one that fits the needs for Criteo. So we do hour-long manual tests, and after a while, we realize maybe we didn't pick the best options in hardware to be able to have the maximum performance. So we change the BIOS option, and now we need to start over and do all the tests again. We then need to test another component because maybe we don't want this CPU or this disk. So we change it, and it changes everything. So we need to redo all the tests. And that's a very error-prone process because if at any given time someone does a copy-paste mistake, it will invalidate the results. Sometimes it's even worse. We might find there's an issue and the BMC is reporting inconsistent information, so we need to cross this information with our PDUs. And yeah, you get the idea. It's a long process. It can be error-prone. I saw some green thumbs raised here. Thank you. In general, when selecting a server, combinatorics will play against us, by which I mean that we have many dimensions when we need to pick a server. We look at what's available on the market, and each dimension will multiply the available choices, whether it's the chassis type, is it a 1U server, 2U, even more, is what type of component we put inside the server, depending on the CPU, disk, etc. It will change heavily how it behaves. And even the components, they have another issue, is that we can put multiple of them. So the number of components we'll put will also add another dimension. So we need to reduce this, and usually we just look at the paper specifications and do a pre-selection. After this pre-selection, we now have a new approach at Criteo that's different than all this manual testing, is to do automated benchmarking with our own internal tooling. So we built a tooling to orchestrate benchmarks, make them reproducible, make it modular so that we can plug new benchmarks inside the tooling, and make everything automated. We don't want to have any mistake in the way it's run. So everything is automated and reproducible. This orchestrator will run the benchmarks, and with each one, we'll measure everything about the physical environment, the power consumption, the thermal behavior, the various temperatures that we can have in a server, the fans, everything. Everything is measured, and then everything can be compared across different servers, across different runs on the same server, but maybe with a different CPU, a different configuration option. And we even added something specific to comparing if we have a chassis that can have multiple servers inside it, being able to see the environmental information of the chassis next to the benchmark results of every server. And today we are introducing Hardware Bench, this tooling we have been developing as open source, and you'll be able to download it right now and try it by yourselves. And that's something we'd like you to do as on-premise user. Use it, give us feedback, tell us how we can improve and how we can improve it. We also expect vendors to try it and criticize it. We know that some things might not be perfect. We might want to improve some things and give us advice. We want this tool to be used as a platform to exchange with vendors. And in fact, we've already used it to find issues on hardware. And because it has traceable results, every test that is run is logged. All the software environment as well as the physical environment is logged. And it's reproducible. Just by sharing a config file, you can rerun the same tests. It can be used to exchange based on accurate information and not just, I did this, but okay, what's your environment? No, everything is logged and traced. And of course, contributions are welcome. Here's an example of how we can use the graphical part of the benchmarking to compare, to view results, to compare things. Here's a specific test about spiking. Spiking is where the thermal behavior of a server might sometimes be wrong, because if your workload is runs in a very short time regularly, you might have the fans at full power all the time, and that's an issue. And we built a tool specifically to detect that. Another sample, here's a comparison of multiple servers inside the same chassis with the performance, with the temperature and fan speed. Here's a comparison, a graph generated comparing multiple CPUs, the absolute max performance we can get on a given test. Here's a float benchmarking. And it's a tool that will generate with a single run thousands of graphs. And we picked a few here that might be interesting. And some might be the one we care about. For example, we care about optimizing performance per core, per watt. And this is a graph comparing this, because we have the environmental information, the power consumption, and the performance, and it's generated automatically. Let's go now to production. We know the production is, we selected the server and it's now in production. It's usually the biggest part of its life cycle. It's the way when it's running applications. But first, let's take a step back and let's look at who is responsible for production inside Criteo. We have, of course, the business apps, which is what brings money. They are built on top of high-level platforms, so they can share services and things specific to Criteo. Those platforms are built on container platforms because we like to run on bare metal. So application at Criteo run on bare metal via containers. And those are built on OS and low-level services, which are themselves built on the hardware, the servers, which we are running ourselves here in the hardware team, and which we are talking about in this talk. So usually at Criteo, we have what we call a happy path, which is the biggest part of infrastructure. We have internal customers that regularly update the firmware of their servers. We auto-detect many types of different hardware failures, like if a DIMM fails or a disk. The internal customer, if there's a hardware failure detected, will automatically release the server and allow us to create automatic tickets to do interventions and things like that. And we have, on the other side, what we call the long tail, which is a small number of customers that might be running Windows, for example. Criteo is traditionally a Windows shop. It used to be a full Windows infrastructure. It's no longer the case, but that helps us for managing the infrastructure, but we still have a few. And some bare metal users think of servers as pets, not cattle, and that does not help when we want to automate everything. And in general, I talked about firmware updates. We think that firmware management is pretty hard on servers. There are many impossible tasks out of the box. I see many green thumbs. Like, for example, you're on the host, you want to list all the firmwares, their available versions and updates, and that's impossible to do with many server vendor tools. Getting an accurate changelog when we have a firmware update is also very complicated. Sometimes we just get bugs fixed. We also lack common tooling to do updates, and we lack precise control of firmware updates. For example, we like to do canary testing. We don't want to update the firmware for a given machine for all the servers in case it causes production issues. So we have built this tool internally, but it's not something that's available out of the box and automatable. I invite you to see Erwan's talk at the Open Source Firmware Conference. It talks about how we care about open firmware and all the challenges we have with managing firmware at Criteo. In general, we have here a small wish list of what we'd like to see from server manufacturers to improve firmware management. We'd like to see vendor agnostic tooling. We'd like to be able to automate firmware distribution. The goal here is to target users that care about automation, like SREs. So we want to have a toolbox with APIs and versus a packaged tool. We don't mean that vendors should stop shipping packaged tools. They are useful for many users, but that's not what we care about. We care first about having the tool set to be able to build an automation in our infrastructure. We'd like vendors also to participate more in open source tooling. Here we propose LVFS and firmware update daemon, which is a response to the automated firmware distribution and application and common tooling. We know it's used with a high degree of success in desktops and laptops, and we think it can be adapted to servers. It's not perfect, but it's the best solutions that could match our needs. DMI decode, for instance, it's a tool that's used to get information from the DMI tables. We'd like to give a shout out here to HPE, who has been contributing recently of decoding vendor information from the servers, and it can benefit everyone. There's also smartphone tools for disk vendors, NVMe CLI, and well, you get the idea. In general, at Criteo, we think open source is a major differentiator, and we care about open source, whether it's in our tooling, firmwares, or even hardware. When monitoring, when managing production, we need to do monitoring. I talked earlier about how we monitor for hardware failures. And for that, we use Redfish, which does out of band monitoring on the BMC. And Redfish is a very useful tool. We managed to use it, but it often feels inadequate. For example, new specifications might sometimes be slow to arrive. I'm talking about PLDM, which solves many firmware issues, but it's not available for all types of firmware. Redfish lacks certifications, official certifications. The DMTF consortium has test suites and profiles, test suites you can run, but they think it's customers' responsibility to pick which profile they care about and tell that to vendors. So often that means that we might find metrics that can be vendor specific or under documented, and we might need to reverse engineer them to know what they mean. For example, when we want to monitor, let's say, power, is this what exactly is measured is hard to know. And it's easy in general. We've found on various implementations to find inconsistencies in the way Redfish information, in new Redfish information, in the way it's managed across servers, even sometimes across updates. And we think it might be, maybe it's related to the lack of certification. I don't know. So when monitoring, there's always the question of should we do in-band or out-of-band? At Criteo, we are lucky enough to have to be single tenant, mono-tenant, so we are able to run in-band monitoring. Of course, out-of-band is useful. We know it does not impact customer workloads, but the way we build it, so the way to build it often means it's not designed for automation. For example, I told you we are detecting hardware failures automatically. Unfortunately, if you want to develop the same thing, it's very hard because you don't have in advance the list of error codes or even a test. If you want to test can I detect if DIM has failed, you need to wait until you have a failure server with the failure, and then you'll be able to see the exact error code that you can detect or error message. Sometimes you can find specific errors that are not decoded. For example, an MCE from a CPU that might not be decoded for some reason, or BMC error that you don't know because you've never seen it before and it's undocumented. In general, I want to emphasize that it's hard to automate, so detection. And sometimes you might get an error and you don't know the gravity. What kind of action should I take? Should I replace the motherboard? Should I just ignore it? I don't know. And we've also found that in-band monitoring is still necessary in our case. There are some errors that can't be detected without in-band monitoring, for example, with storage disks, SATA. We know NVMe has management interface, so that helps a bit here, but it's still not there. And some cases, like if you have a CPU that's throttling and you have a performance issue, you cannot detect it out of band. So you need to get information from the host. And in general, what we've seen is that vendors can't see what we see. Usually, a vendor engineer has access to maybe many servers, but it will be a limited set of servers. And maybe the exact configuration we have, they won't even have it in their test lab. And we monitor and see issues on thousands of a single type of server. So every time there's an issue where something happens and it's in rare conditions, and we know it's in our infra because a few percent of impacted servers will mean it will be a huge impact when you multiply by the size of the infrastructure. So our proposal today, we don't know exactly how it can be implemented. Our proposal today would be to transparently share the monitoring metrics with vendors so that they can be able to see what's happening with the hardware and that they can anticipate support. Do not hesitate if you have any remarks, if you want to say something. I see a lot of green tabs. Thank you. Thank you. So I talked about how they could anticipate support. So what's support? In general, at Criteo, we support multiple different server generations. I told you earlier we were 9 on the hardware team, but there are only 4 people responsible for keeping them, keeping the server hardware working and maintained. And those 4 people, so they take care of servers, and at Criteo there are other people that are updating the business applications, the OS, the software. That's they are basically doing the maintenance and upgrading everything. And that works over multiple different server generations. And we find that vendors, they don't have the same approach to software maintenance in the way they upgrade tooling and firmware. Will often get maybe security fixes and some bug fixes, but it's not built for scale. And that stems from the fundamental business model of server manufacturer. They are selling servers and warranties, and not necessarily software maintenance. Sometimes we'll have end of life at vendor that's very different than the one from us. We have multiple generations, and at some point they might say, "Oh, I'm sorry, we get no more bug fixes for this hardware." Maybe if you get the next generation, the bug will be fixed. And sometimes no more new features, and the features on the next generation might already be freezed, so it will be the one after that. What we find is we lack a clear communication in advance of how the software will be maintained. When I'm talking about software, I mean the tooling, of course, but all the firmwares that can be in a server. As you know, there can be tens of them. And maybe we should find a way to change this business model. Maybe we'd like to have a longer maintenance. I don't know who here would like a longer software maintenance for the tooling in their servers. And who would be ready to pay for that? Oh, still some green terms. Okay, so we know already that we pay for warranties, but it's not the same. It's for break and fix and part change and things like that. So yeah, it's just an idea, maybe something that should be explored. And when we talk about support, we also talk about engineering support, and sometimes you have this server that has an issue, and you notice you have another server that has this exact same issues. So you might think it might be hardware related, and you start investigating. You spend hours, sometimes days debugging it, and in the end you find yes, it's indeed related to hardware or low-level software, firmware, I don't know. So you write a detailed bug report for the vendor, and you open a ticket. And the first answer you'll get is, have you tried rebooting the server? And of course, you get the idea, of course. That's understandable. That's the way support works when you have the first level of support. And in general, we found that it's hard to talk to engineering. At Criteo, we are lucky enough we managed to open a few doors. But we know it does not scale for all customers because vendors need engineers to design, new servers, and not necessarily talk to customers all day. And the lack of, even when we manage to talk to engineers, we find we lack the specific hardware tools to be able to exchange information. So we want to extract traces, crash logs, and send it to them. We don't have the tools. So even if we have them, we find they're not built for scale. So we want to automate that, be able to send all the crashes we have. It's not made for that. And the support will be geared toward opening tickets for one given server with a serial. But now I have 10 or 100 servers exhibiting an issue. Should I open 100 tickets, change 100 parts? Maybe not. So scale is not considered in the way support is designed at server manufacturers. And I told you sometimes we might not get bug fixed. Of course, it's a lie. We know we are getting bugs fixed. We get regular firmware updates. And between every software updates, you often find in those changelog, in rare conditions, you know that between every message like that, there's a story of someone who debugged and managed to find an issue and get it fixed. Sometimes it's Criteo, sometimes it might be you, I don't know. And in general, we need to get those bugs fixed. Because if you have an issue with 100 of parts, will you be able to change all of them? Sometimes it's not even possible. You don't have the stock of parts to be able to do that. So in general, what we found, a good recipe to get issues changed is to have good written reports. And that's the one that have the most impact on the long term. Even if it's a small bug that can be worked around, the good reports, they get forwarded inside the server vendors. The people, the engineers, end up reading them, even if you don't see this, and it might end up getting fixed, even if it's on a longer time scale. Sometimes 18 months, 2 years, it's entirely possible for this type of things. So we've talked about support. Now we need to get the server repaired. We need to change those parts. Sometimes they just fail. And the way we do that at Criteo is with a semi-automated pipeline. I told you we have monitoring, it detects issues, and it's RMA oriented. So we change the parts, we order new parts, we change the parts. That's how it works, and it's throughput optimized, which means we want to change as many parts as possible. When a technician goes into the data center, we want to optimize their time and repair as many servers as possible. So it's throughput optimized and not latency. So we don't really care to change a part in a short time. We don't care about one-day interventions, for example. But this equation might change in the future. We know the densification is coming. Vertical scaling is where you get TCO improvement. That's always been the case. It's still true. And if you scale vertically, it means you have less servers. So they are bigger and maybe more expensive, but you have less of them, and they can become more precious. And that it means it changes the equation of how long you can leave a server unrepaired. Also, we know there's a push in the industry for longer server lifetimes with longer warranties. It means if we want to do repairs, we want to keep a server longer for sustainability. If we want to repair it towards the end of life, whether it's if it's a 3-year warranty, we'll probably change more parts if it's a 7-year warranty. Because through the end, it should be mechanical. There will be more failures. And at Criteo, we also want to automatize part ordering. So we care about APIs in the RMA ordering process. But of course, the best part change is the one that does not need to happen. And in the industry today, there are solutions that are underused. For example, ZDEC has, for DIMMs, they have designed this thing called PPR, post-package repair, that allows doing detection of failed blocks in a DIMM, in RAM, and changing them with spares. And this is already used in production lines. And unfortunately, we find that this feature is not available enough in servers. And we'd like to be able to use it, so because it means changing less DIMMs, and everyone wins here. We also care about firmware remediations. So, and if we can fix the issue, that means not changing a part in software, it's always better than changing the part. Sometimes we might get BMC that would tell us, oh, this part is failing, but maybe it's not. So maybe there's a bad diagnostic that will generate false positives. Sometimes we might find that it says it's failing, but in fact it's a software bug, and we need to update all the firmwares, and maybe sometimes multiple different ones before the server can work properly. And sometimes we need to report this as a bug and getting fixed, as I said earlier, and it will prevent changing parts. And when a server comes back from repair, its parts has been changed, how do I check that it's still a good server? Is it in good health? We have some in-house tools. We are able to detect if a server is working properly. But in general, we find that we're lacking tools to identify working hardware. Is it working? And sometimes it just identifies the hardware. Sometimes we want to know what's in a server, and we can't, because we might get a generic part number, but in fact, under this part number, there are maybe 10 of references. And it raises the question of how identical do we want a server to be after repair. We know that through the life cycle of a server, it might be impractical to always have one part for one type of server, and sometimes we might have functional equivalents. But the issue is that functional equivalents are not always equivalent. And we've already had production issues where a functional equivalent part caused production issues because it did not behave the same as the way the server behaved initially. And automating the checks of new parts, so we have a new functional equivalent, is very hard. We can't automate that. We can't also automate detection, as I said. So we've repaired the server, we've extended its life, and now we are reaching towards the end of its life. It's decommission, and we want to decommission the server responsibly, because we care about sustainability, we care about the planet, but we also care about value preservation of a server, because we resell them through brokers, and we do value sharing deals. So it's in our best interest that the server value is as high as possible, even after its end of life. So for that, we care about being able to put back a server in its original, let's say, condition. For example, if we change the firmware with OpenBMC, we care about root of trust, transfer of ownership. We know some vendors are working heavily on that, and Vincent gave a talk on OpenBMC at the OCP Summit a while ago. So being able to put back the root of trust of a server for the BMC from Criteos to the manufacturers, so it's sellable, it's something very important. We also think that in general, processor fusing isn't a properly thought feature, security feature. Sometimes CPU vendors might design features so that a processor can be fused and only be used with this manufacturer or this motherboard. And that reduces the value of the server or the part itself. because it means that a given CPU can only be used with this server or this server manufacturer. And we think the security properties here aren't properly thought, and we could improve, this could be improved without having the value destruction part. So, yeah. I see many green thumbs, thank you. And finally, there's the issue of data confidentiality. Sometimes you need to resell as a hard disk as well as storage devices. And we have tools to make sure that no customer data stays on it. But we lack proper tools, proper open source solutions that can be certified and give a common solution, acceptable solution for everyone. And we know some of you here in the room have developed data confidentiality solutions for reselling storage devices. Let's maybe discuss this after the conference. Maybe we can find a common solution to work together. So we are at the end. In summary, what did we see today? Everything we talked about, we have summarized the way we work in the hardware team on our operating principles manifesto, our hardware manifesto. It's the way we want to work with server vendors in general, the way we want to show expertise. We care about openness. For example, we want we care about open source, of course, but also we want to have solutions that are for everyone. We care about, as I told you, expertise, and we want to access better engineering support. And in exchange, we only raise issues that are pertinent. And of course, we care about efficiency, whether it's for reducing our footprint or for optimizing, of course, the total cost of ownership of servers. So you can check this manifesto on GitHub. And that's it for me. Thank you. Any questions?
Yes. It's okay. You are ready to share also the profile.
So let me repeat. Okay, all right. Sorry.
So you were speaking about automation, which is great for benchmarking and validation. But what I think is missing from a CPU vendor, at least standpoint, is really your application profiling. You can extract a lot of information out of these benchmarks, so floating point, integer, bandwidth, and so on and so on. But we just don't know if any of them will fit to your application and your needs. And so we can't, I would say, change anything for you or adapt. You will have to consume what we produce. So what's your thought on this?
It depends. It depends. Like everything, it depends. We are not opposed to sharing application profiles if we are able to do proper measurement and we know it will be only related to low-level information on the instruction profile and what is run. Why not? We are open, of course, to sharing that with CPU vendors. Yeah.
Okay, thank you.
Thank you. You said earlier that you needed pre-EOL notices for end-of-life hardware or generational. Do you have a time frame you would love? Please don't say ASAP. Do you have like 6 months, 18 months, a year? What would you prefer?
It's not that we would want to know about end-of-life notices. We've bought the servers; they are in production. What we care about here is software maintenance. And even if the server is end of life, we want server vendors to think of their tools, their firmware, as software that can be maintained in the longer run. And at least it should match, well, ideally it should match the duration of the warranty, for example.
Yeah, end of support.
Yeah.
Okay, thank you.
And yeah, if we can know that in advance, when we buy the server, it's of course much better. Because that's also what's lacking.
So it's that selling point that you would love to know at qualification point.
Yeah.
For a given flavor, you would like to know how it will end.
Yeah, exactly. It's
Okay.
exactly that. Yeah.
Even before buying.
You don't see it, Maliki, but I see some green tabs.
I only see blue tabs. Sorry.
Let's go.
So you were also asking for, I would say, long-term support on the server. I would like to understand, really, what for how long we are speaking in terms of duration of support, because so we are all together here. So we have CPU vendors, storage vendors. So as you know, server is fairly complex. You have firmware everywhere, operating system everywhere, and so on. So it will have to be, I would say, a common discussion. This is also why I think PremDay is done. But at the CPU level, so we do have, I would say, a quite secured and robust process on this. But everybody, would say, will agree that if the processor stops some support, the server manufacturer won't be able to support it either, and so on and so on. So I would like to understand for how long, indeed, we should update, for example, the microcode and deploy a security fix, solve any CVE which comes up, and so on. And indeed, also same question, if you are also indeed willing to pay for it if available.
Usually at Criteo, we perform all microcode updates through the lifetime of the servers. So we are very following those updates even before the OS updates them. How long support would we like? I think through the duration of the server lifetime. And today we are aiming for 7 years of server lifetime, but we know that when we buy a server, it might already, the design would have ended maybe 3 years earlier for the CPU vendor. So it would mean 10 years, I guess, for Criteo. And I know some in the room would like even longer. But I'll let them maybe relax.
I can give you an example. If I'm buying the last server which is produced from a particular vendor product, I'm buying the last server from the product line. In my condition, it starts its life. So I will have, from the last server I'm buying, it will have to live for 5 or 6 years. But from the last one that have been produced in the series, which is maybe 10 or 12 years after the product have been designed. So for us, from the user perspective, the support starts when we buy the server. And from this point, for you as a producer, it's a very old product already. But for us, this is a brand new one, and we will have to support it for 5, 6, 7 years. So I would say from the ignition point of a product, it may be 10 or 12 years, something like this, at a minimum. It's very long, actually.
And if you expect to resell your servers once they are decommissioned, for them to still have some value, it's better if the components are still supported. Maybe not very long, but still under support.
Yeah.
I think the message that we are trying to send is also to consider the generation over generation as a continuum. Not, you don't design a generation and then it's designed, we don't touch anything anymore. We would rather see something like, improvements are, made from, they start at generation N, but they are backported to generation N-1, because often it's not that difficult to do. At least that's the message that we are trying to send also.
Yeah, it's time. Okay, thank you. We'll stop here. Thank you very much.